Have you ever looked up at an airplane soaring through the sky and wondered, how is that even possible? It seems like magic, doesn't it? But the truth is, flying is not magic at all. It's all about science. Behind the wonder of flight are a few key principles that allow these massive machines to defy gravity and take to the skies. Let's embark on a journey to understand the fascinating science behind how airplanes stay in the air. We'll explore the four forces of flight: lift, thrust, drag, and weight, and how they work together in perfect harmony to make flight possible. Fasten your seatbelts and get ready for takeoff. Imagine a seesaw at the park. To keep it balanced, you need equal weight on both sides, right? Well, flying is kind of like that. An airplane needs to balance different forces to stay in the air. These forces are lift, thrust, drag, and weight. Think of them as four players in a tug-of-war, each pulling on the airplane. When these forces are balanced, the airplane can fly smoothly. Throughout this video, we'll break down each of these forces and how they contribute to the miracle of flight. Let's start with the most important force for flight: lift. Lift is what allows an airplane to rise off the ground and soar into the sky. Without lift, flight would be impossible. Lift is the force that pushes the airplane upward, counteracting the pull of gravity. Gravity is constantly pulling everything towards the earth, but lift works against this force, allowing the airplane to ascend. But how is this upward force generated? It's all about the design and shape of the airplane's wings. The answer lies in the special shape of an airplane's wings. These wings are not just flat surfaces, they are carefully engineered to create lift. Airplane wings are designed with a curved upper surface and a relatively flat lower surface. This unique shape is crucial for generating lift. This shape is called an airfoil. The airfoil design is what makes it possible for airplanes to fly. When the airplane moves forward, air flows over both the top and bottom of the wings. The movement of air is essential for creating lift. The curved top surface forces the air to travel a longer distance than the air flowing under the wing. This difference in distance affects the speed of the air. According to a scientific principle called Bernoulli's principle, faster moving air creates lower air pressure. This principle is key to understanding how lift is generated. Therefore, the pressure above the wing is lower than the pressure below the wing. This difference in pressure is what creates lift. This pressure difference creates lift, pushing the airplane upward. As the airplane gains speed, the lift increases, allowing it to climb higher and higher into the sky. This is how airplanes are able to take off, fly, and stay in the air. Understanding lift is fundamental to the science of aviation. It's the principle that makes air travel possible, enabling us to explore the skies and connect with distant places. So next time you see an airplane soaring above, you'll know the incredible forces at work that keep it aloft. Bernoulli's principle is a fundamental concept in fluid dynamics. This principle, named after the Swiss mathematician Daniel Bernoulli, is crucial in understanding various phenomena in both natural and engineered systems. It helps explain how lift is generated, which is essential for the flight of airplanes, the functioning of carburetors, and even the way a soccer ball curves in mid-air. Simply put, Bernoulli's principle states that as the speed of a fluid like air increases, its pressure decreases. This inverse relationship between speed and pressure is a cornerstone of fluid dynamics. Think about holding a piece of paper curved slightly downward in front of your mouth and blowing over the top of it. This simple experiment can vividly demonstrate Bernoulli's principle in action. The paper will rise. This is because the faster moving air above the paper creates lower pressure, causing the higher pressure below to push the paper upwards. This phenomenon is not just limited to paper. It can be observed in various other scenarios, such as the lift generated by airplane wings. The same principle applies to airplane wings. The wings are designed with a special shape known as an airfoil, which allows them to manipulate the airflow in such a way that lift is generated. The shape of the wing, along with the angle at which it meets the oncoming air, called the angle of attack, determines how much lift is generated. The airfoil shape causes the air to travel faster over the top surface of the wing, creating lower pressure above the wing and higher pressure below it. The greater the angle of attack, the more lift is produced up to a certain point. However, if the angle becomes too steep, the airflow can become turbulent and the wing can stall, losing lift. This delicate balance is crucial for pilots to manage during takeoff, flight, and landing. Understanding Bernoulli's principle and the factors that affect lift is not only important for aviation but also for many other fields. Engineers, scientists, and even athletes use this knowledge to optimize performance and design. From the wings of birds to the sails of boats, the principles of fluid dynamics are at play, showcasing the elegance and power of Bernoulli's discovery. Section 5. Thrust, pushing forward. While lift gets the airplane off the ground, it needs a force to propel it forward. That force is called thrust. Thrust is generated by the airplane's engines. There are different types of airplane engines, but they all work on the same basic principle. They push air backward, and in doing so, create a forward force. This force counteracts drag and allows the airplane to move forward through the air. The amount of thrust an engine produces depends on its design and power. Larger, more powerful engines produce more thrust, allowing airplanes to achieve higher speeds. Section 6. Drag, the resistance to motion. As the airplane moves through the air, it encounters resistance. This resistance is called drag. Drag acts in the opposite direction to thrust and slows the airplane down. Drag is caused by the friction between the airplane's surface and the air molecules. The shape and size of the airplane, as well as the smoothness of its surface, all affect the amount of drag it experiences. Engineers put a lot of effort into designing airplanes to minimize drag. This is why modern airplanes have sleek, streamlined shapes and smooth surfaces. By reducing drag, airplanes can fly faster and use less fuel. Section 7. Weight, gravity's pull. We all know that gravity is the force that keeps us grounded. It also acts on airplanes, pulling them down towards the earth. This downward force is called weight. Weight is determined by the mass of the airplane and its contents, including passengers, cargo, and fuel. The heavier the airplane, the greater its weight and the more lift it needs to counteract the pull of gravity. During flight, the lift generated by the wings must be equal to or greater than the weight of the airplane to keep it in the air. Section 8. Aircraft design, shaping the skies. Designing an airplane is a complex dance between art and science. Engineers must consider all four forces of flight when creating an aircraft that is both safe and efficient. The shape and size of the wings, the power of the engines, the materials used in construction, and countless other factors all play a role in determining how an airplane will fly. For example, passenger airplanes have large wings designed for efficiency at cruising speeds, while fighter jets have small, swept-back wings built for maneuverability at high speeds. Through careful design and innovation, engineers continue to push the boundaries of flight, creating airplanes that are faster, more fuel-efficient, and capable of flying higher and farther than ever before. Section 9. Conclusion. The continued wonder of flight. So there you have it. The journey of flight from its humble beginnings to the sophisticated marvels we see today is nothing short of extraordinary. The magic of flight is not magic after all, but the result of a fascinating interplay between the four forces of flight: lift, thrust, drag, and weight. These forces work in harmony to lift the airplane off the ground, keep it in the air, and bring it back down safely. From the curved shape of a wing, which is designed to create lift by manipulating air pressure, to the powerful engines that propel an airplane forward, generating the necessary thrust to overcome drag, every aspect of an aircraft's design is carefully considered to achieve the perfect balance of forces needed for flight. Engineers and designers spend countless hours testing and refining these elements to ensure safety, efficiency, and performance. Next time you watch an airplane soar through the sky, remember that it's not just a machine, it's a testament to human ingenuity and perseverance. Take a moment to appreciate the science at work, the principles of aerodynamics, the precision engineering, and the relentless pursuit of innovation all come together to make flight possible. It's a testament to human ingenuity and our endless fascination with conquering the skies. From the Wright brothers' first flight to the latest advancements in aviation technology, our journey has been fueled by curiosity and determination. And who knows what incredible advancements in aviation the future holds. With the rapid pace of technological development, we might soon see airplanes that are more efficient, faster, and even more environmentally friendly. Perhaps one day, we'll even be flying among the stars. The dream of interstellar travel could become a reality, opening up new frontiers and possibilities for exploration and discovery. So, as you look up at the sky and see an airplane passing by, let it remind you of the incredible journey we've undertaken, and the exciting future that lies ahead. The wonder of flight continues to inspire and captivate us, pushing the boundaries of what we can achieve.